Good afternoon. Thank you so much for attending the College of Engineering's An Inside Look series, which is in collaboration with the Dean's Leadership Board. And the series aims to provide an inside look into industry and a chance to learn about potential internships or entry-level jobs. It also seeks to acknowledge the importance of diversity and inclusion in the workforce. Today is our final event in the series, and just so you know, all of the events have been recorded and they will be shared with all students at a later date. I encourage you to ask questions as we go through the event today by putting them in the chat box. So we will be moderating that and having an optional Q&A at the end. So without further ado, let's begin. Today we have presenters from Northrop Grumman, and to begin our event, I would like to introduce Norm Eng, Vice President, Palmdale Aircraft COE and Oklahoma City Engineering. Norm.
Thank you very much, Chelsea, and welcome, students of Cal Poly Pomona. My name is Norm Eng, and I want to have an opportunity today to share with you all the things that we do at Northrop Grumman. And I have several handpicked leaders from around my organization to share with you what a day in the life looks like as an engineer. I appreciate how hard it is that you're working, because Cal Poly Pomona is a really, really great school. And I'm sure getting through that is a very challenging thing to do because of how awesome Cal Poly Pomona is. We've been partnered with Cal Poly Pomona in so many different ways for so many years. For instance, we have a collaboration project with Cal Poly Pomona that dates 10 years, where we actually have students lead a program, a project, to be able to create multiple UAVs and a ground station, unmanned ground vehicle, unmanned submarine, and collaboratively cooperate to complete a mission. That's what real world engineering is like, and we wanted to give students at Cal Poly Pomona, as well as Cal Poly SLO, the opportunity to collaborate with each other and see what a day in the life of an engineer is. And more specifically today, you're going to see, if you were part of that project or if you weren't part of that project, you're going to see what all the fruits of the efforts that you're putting into studying is going to pay off, because we have fun. And the problems we tackle are really hard. And that's what we as engineers love. We want things that have never been done before, that the planet has never seen before, doing incredibly important things for our nation and our customers. So with that, I want to start by playing a video to kick off what we call defining possible. Let me get the right thing here and play.
Somewhere.
Oh, there we go. My apologies. Here we go.
Somewhere
Past the edge of convention,
beyond the boundaries of tomorrow,
lies a special kind of impossible.
a kind of impossible.
Where pioneers forge ahead.
Where no idea is too bold.
And no challenge too great.
Because making a 200-ton airplane disappear is impossible.
Until it's not.
Predicting cyber attacks before they happen is impossible.
Until it's not.
And solving the mysteries of the universe is impossible.
Until it's not.
It's our job to break free from what is
to what could be.
Ready to leave the boundaries of what's known?
To define possible.
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 Great. I was happy to kick off our talk today with that video, Defining Possible, because we do take what normally would be impossible by any other group into what's possible. So to start us off, give you a little background about myself. I've been at Northrop Grumman my whole career out of college. I did graduate from an engineering school as well, Rensselaer Polytechnic Institute in New York, and I've spent over 34 years with the company doing some extraordinary things in aerospace. As we do some extraordinary groundbreaking work. And if you decide to join us at Northrop Grumman, you'll have the opportunity to do some groundbreaking work as well. And now I'm the vice president of the Palmdale Center of Excellence, that's what COE stands for, but also the Oklahoma City Engineering Organization. So my programs span from the B-2 bomber, which you'll get a glimpse of today, the F-35 fighter, which we're partnered with Lockheed Martin on, the F-18 Navy fighter, the Hornet, which we're partnered with Boeing on, a number of unmanned systems like Global Hawk and Triton, and some other things that we can't discuss, but it's cool. So with that, I'm going to share with you one of the things that we do down at Redondo Beach before I turn this over to Curtis, and that is the James Webb Space Telescope, which is going to be launched later this year, and is meant to be the successor to the Hubble Space Telescope.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space, at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures. Temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown. A 5-layer, tennis court-sized sun shield that blocks heat from the sun, earth, and moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, like origami, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deploy Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold Webb. After this delicate dance, Webb's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
I have the pleasure of introducing Curtis Hudson. He's the Department Manager for Electronics and Payloads and a veteran of the Marine Corps, having spent 11 years and 4 combat tours there. He came over to Northrop Grumman and worked in multiple programs, first as a weapons integration design engineer, then as a flight test lead. Now he runs a department of engineers where he helps them in their career become whatever they want at Northrop Grumman. Curtis has a Bachelor of Science in Aeronautics with a minor in Aviation Management from Embry-Riddle. Welcome, Curtis.
Welcome. Thanks for that, Norm. Hello, everyone. So, like Norm was saying, I'm a Marine Corps veteran. I didn't take the normal path like some of you are, but that just goes to tell you, hoorah back, whoever that was. But that just goes to tell you that any veterans out there that decides to take a different route, if this is where you want to go, the opportunities are there. If you know any veterans, let them know the same thing. Okay, so now my role in Northrop, like Norm was saying, I am a department manager for electronics and payloads. So I've been able to move up in the leadership chain, and now I'm responsible for over 100 engineers in the electronics and payloads department. I'm here on behalf of the SEEP Directorate, Systems Engineering and Electronics Payloads. So I'm representing another part of the overall directorate as well, which is, as you can see with the system engineering slide, even though that isn't my department I'm responsible for, we all share responsibilities across that directorate, and I'm here to represent them as well. So I'll start off with the systems engineering side of things. We see the slide right here. Excuse me. It lets you know the discipline, what system engineering is, the logical sequence of decisions, but I'm not going to read directly from the slides. I'm just going to give you an overall breakdown. So the simple answer, a systems engineer oversees the engineering, business, and the management aspects of a project or a system. They make sure that all the parts work properly together. So system engineers, they're concerned with the big picture of a project. I know in the engineering world, we can get hyper-focused on our particular part of the overall effort of the overall project. The system engineers aren't afforded that luxury. They have to think big picture in the end of the life cycle. So they're not only concerned with the engineering aspects, they're concerned with the costs, schedules, and other issues that may arise with that particular project. So for example, we'll use something that everyone's familiar. We all have our cell phones. Everyone has a cell phone these days. So the cell phones, they have mechanical portions of it. They have electrical portions of it. So you require mechanical engineers and electrical engineers. The system engineers, they are concerned with all those aspects and then some. They can be the project manager, focus on the resources and schedule. They can be quality engineers who are focused on the quality of the parts and the end product, or they can focus on the marketing. They understand the customer wants and needs. So there's system engineers handle interdisciplinary issues and problems. They make tactical and strategic decisions at every level of an organization, from the entry level, the napkin phase, I like to call it, all the way to the end of the life cycle operations, sustainment at the engineer position, all the way up to top level management. So system engineers, they have a lot of responsibility. They play a big role in the success of a product. Now, the electronics and payloads portion, this is my department, so I'll try to keep my biases aside. But electronics and payloads is pretty self-explanatory. So in order to understand what an electronics and payloads engineer does, you need to understand what a payload is. So a payload is the carrying capacity of an aircraft or vehicle, usually measured in the terms of weight or some other external factor. And depending on the nature of the flight or the mission, that payload can be considered cargo. It can be a passenger, a flight crew, munitions, instrumentation, whatever other experiments that our big brain employees at Northrop can think of. Anything that can be considered a payload. communications equipment. We also have communications engineers that's not called out explicitly, but they're part of the electronics and payloads group. They're responsible for the research and the design and the development of the communication portion of equipment and the systems, as on the air vehicle, or depending on the platform, the structure of the platform, the ground stations. We're 2021. We're thinking ahead. So a lot of our systems may be unmanned, can be flown unmanned or manned. So we need to have that ground station in place too. So that's where the communications engineers come into play. So not only are we concerned with the payload portion, but the communication portion as well. Then you have avionics engineers. We're talking, the infrastructure, the computer coding languages, all that plays into the electronics and payloads department. The E&P engineering means you determine a problem, you research the problem, you find the solutions, possible solutions for those problems. You create a product that is fit for the purpose or the mission and the I guess that's the simplest way to describe it. It's a lot more that goes to, but if I'm breaking it down Barney style, that's the simplest way I can describe it. In our area of expertise, in particular, we confirm what the product needs to do, what type of budget we're working with, and how much time we'll have to complete it. That's the first step. And then we take that and we create a product and we deliver that package in the entire life cycle, if I'm breaking it down. Then we have our SMC, Systems Management and Control, which is another part of the overall directorate. Once again, it's not called out in the name, but they play an important role in the overall functionality of our directorate programs and the company. So, SMC, the main project, the departments that they have the project engineering, the verification, and the CMDM, or configuration data management, the process and procedures. And as you get involved in this, it's the process and procedures, those will save us. Those can make or break a program. If we don't have the proper processes in place and procedures in place, that can make or break us. So we use them, we rely on them to help us manage the suppliers properly, integrate the configurations from sub tiers all the way up to the primes, and they keep us honest. I guess that's another simple way. With the proposals, they help us make sure we are operating in the best interest of ourselves as a company, and we're providing the best possible product to our customer. Then we have survivability, a critical part of electronics and payloads. Almost, me personally, I think they're so important that's why they're broken out to a separate, a separate discipline altogether. Now, when we're dealing with survivability, we're thinking the use of stealth technology to reduce RCS, or radar cross section. The radar cross section is the airplane's physical geometry and exterior features, and we want to take a larger signature and reduce that down. So that's what survivability engineering comes into play. So the survivability engineer, they focus on that different technology methods to help us increase the survivability of the aircraft. What good is an aircraft if they have a large signature, or they can't defeat some of the enemy radar systems or other anti-aircraft systems that we have out there? So it's on the survivability engineers and their teams to come up with methods to help develop those ways to stay in front of the enemy, data analysis and such. So in short, that's the overall SEEP directorate as a whole is broken down. And if you have any other questions, you can always reach out to me in the chat window and I'll address it. I'll turn it over to you, Norm.
Thank you, Curtis. It's such a large organization, systems engineering and electronics and payloads. And the type of engineers we generally have in that organization are electrical engineers or electrical engineering graduates. There are computer scientists, there are physics majors as well, mechanical engineers. So we have a number of different skills that go into the systems engineering and electronics and payloads organization. The next directorate I'd like to talk about within engineering is the Systems Integration, Test and Evaluation Directorate, which is an organization that actually takes the airplanes and test flies them, tests them in the lab, tests them on the ground. And Adriana Garza has been with the company since 2013. She started in flight tests on the B2 program, which is a great program to start your career on. And then she supported test operations on a Firebird program. The Firebird program is an optionally manned airplane. So it's both a UAV and a manned airplane. She then went on to support special projects as an electrical engineer and is now a hiring manager. So you want to definitely get to know Audrey for the systems integration, test and evaluation. Adriana got her Bachelor of Science in Aerospace Engineering from the Florida Institute of Technology, and she has a program management certificate from the California Institute of Technology. Welcome, Adriana. Thank you for joining us today.
Thank you, Norm, for that introduction.
You bet.
So, as Norm said, I'm part of the SIT&E organization. So what is SIT&E? At the end of our system engineering process, after requirements have been developed, the design and implementation are complete, we move in what's called the integration and test stage. This is where we verify and validate requirements. In order to do this, we need accurate and reliable data. So this is where our instrumentation teams come in. We have teams of engineers and technicians that design, develop, and maintain our instrumentation and data systems. Accurate data is not only important to requirement verification, but is also used to validate simulation models, surrogate platforms, and even develop new systems. So what does a day in the life of an instrumentation engineer look like? So we have mechanical and electrical engineers that are responsible for designing and developing the platforms and equipment used for data collection. This includes, but is not limited to, transducers, sensors, signal conditioners, recording devices, video feeds, and telemetry. We have these folks in the labs. They're ensuring that the instrumentation integrates with the system under test and provides accurate data. And during our flight operations, the instrumentation engineers support the functional checkouts, the acceptance tests, and ensure that the test team is receiving real-time data in the control room. They are always there monitoring the health and status of the instrumentation system. Overall, their end goal is to provide usable and accurate data for our engineers to analyze and verify our requirements. So some key areas of expertise we look for. Individuals that are engineering oriented, definitely with electrical and mechanical backgrounds. Someone that is a jack of all trades and understands the overall understanding of all the different subsystems. Also has to be a team player. Got to work with different engineering organizations, the structural engineers, and understanding their requirements and what kind of strain gauges they need and where, to working with our avionics engineers and understanding what messages they need in order to verify a particular LRU. Just overall, someone that is able to come up with solutions and design with the limiting factors. Our instrumentation engineers kind of get the limited number space when it comes to a system. So beyond our instrumentation, we also have teams in the labs. These folks are focused on ensuring that the new system is safe to deliver to our ground and flight test teams and eventually our customer. They utilize a number of simulators, emulators, and real hardware to test the system, really focusing on testing as you fly. That is the mentality we live by. And they're there to really stress the system to make sure issues are caught in the lab and not in flight. So what is it like being a lab test engineer? In the labs, we have engineers that focus in on subsystem integration. They're the ones there to develop the test procedures, ensure test point execution, and complete the required acceptance tests. They're there to validate the software for the system under test and test it at numerous levels of maturity in hopes of finding issues early on, and then relaying that information to our software engineers and our system test engineers so we're able to get it fixed as soon as possible. In order to actually conduct these testings in the lab, we have engineers that are there to fabricate, assemble, and integrate our test benches. They're the ones to ensure the correct infrastructure is in place and the required hardware and software are ready to go for testing. So some areas of expertise for these folks, these individuals understand the overall mission, how to plan for it. I mean, how will we be using this in the field? We need to make sure we're testing as we fly. They also have an understanding of all the different payloads and communication systems. As Curtis mentioned, we have, all our different avionics, our stores, our, electronic warfare, radar, et cetera. They need to have understanding of that. Also data infrastructure, and then when it comes to autonomous systems, our ground control station and how all those networks work in those communications. So once it's in the labs, we move out into ground testing. This is where we end up doing a complete shakedown of the system to ensure it is airworthy and ready for flight. This is a very hands-on environment, and we test the completely integrated system here. This is also the time we're able to do proof of concept testing on a full-size test article. So very similar to our lab operations, our engineers out on the grounds are responsible for test plan development and execution. They're the ones coordinating our test events, making sure the resources, personnel, and equipment are in place. Leading up to a test event, they're the ones conducting readiness reviews to make sure we're ready to go and we're safe to proceed with test. Once testing is complete, they document their findings and present a test report. And this is what feeds into our requirements traceability. Areas of expertise here, we have our system test engineers. These are the folks that have a deep understanding of the system under test and how it integrates with the overall systems. They're the ones developing the test plans. We have our test conductors. These are the ones actually running the tests. They're the ones responsible ensuring we are executing test points and completing tests. And then our system operators, the ones actually pushing the buttons and exercising the system. Overall, our folks out in the ground test teams are very hands-on. So after all that is said and done, we move into flight test engineering, where I came from and I have a lot of background in. So in this phase, we're really focusing on comprehensive flight tests and ensuring safe and effective flight ops. We need to make sure this article is ready for the customer. So similar to lab and ground teams, our flight test engineers are responsible for the test plan and test card development and also ensuring resources are in place. Unlike our ground test teams though, there's a lot of planning that goes into a flight test event, be it coordinating airspace, range assets, frequencies, etc. We also work with our mission planners to make sure mission plans are in place and ready to go. Some of our flight test engineers end up being certified test conductors. So our test conductors in flight worlds are the ones in the control room talking to the pilot. They are responsible for the real-time coordination of activities with the pilot and ensuring test cards are being followed. So they must be familiar with the pilot workload and the overall test procedure at hand. We also have our test conductor, our test director. He is the experienced engineer in that room that is kind of the supervisor for all the engineers and the test conductors and ensures we are meeting safe and effective flight operations. Once testing is complete, we develop the test plan, send that, and ensure requirements are being met. We also go through and our flight operations teams are there to verify our operating procedures. Our flight test technicians are there keeping the aircraft safe, going through our manuals and making sure that user manual is ready to go for the customer. So areas of expertise, when it comes to flight tests, someone that is easily adaptable, jack of all trades, and you got to be ready to drink from a fire hose. In flight tests especially, end of a schedule, a lot of schedule pressures, things are constantly changing, so you got to be easily adaptable. So thank you, and I'll hand it over back to you, Norm.
Thank you very much, Adriana. That was excellent. So exciting to be part of launching a new airplane or putting a new capability on an airplane and getting everything ready for flight and then watching it take off for the very first time. Couldn't be anything more exhilarating. So thank you very much, Adriana. Tracy Marshall is our software manager, and he recently joined us just a couple years ago, and he joined us working on a number of software programs. In the past, he has worked for on other programs like the B1, the AWACS, and now more recently on the B2 and now other programs. Tracy attended Oklahoma Christian University, where he has a bachelor's in electrical engineering, and then he got a master's in software engineering from the Kansas State University. And he enjoys having fun with his kids and listening to podcasts. So if you have a podcast recommendation for Tracy, he's open for it.
Definitely. Thank you, Norm. Yeah, if you have a podcast, let me know. I'm all about it. I love a good podcast. So what does the software engineering org do? If you think about the body's controlled by a brain. Well, I like to think of what we do is creating the brain for our products. Obviously, we're kind of worthless if we don't have a body to work with, and eyes and ears and other sensors to take in information to do something with that brain, and limbs to actually operate and move around in the world. But we do play an important role in what we do for our aircraft. So Norm mentioned a bunch of different aircraft that his portfolio is responsible for. So the software org is writing software that is actually helping to control those aircraft in different ways. In some ways, it's the mission systems. In some ways, it's flight controls. It varies depending on which aircraft and what contract we have. We go through the whole life cycle of the software engineering process. So we're working up front with the systems engineering organization and what their big picture plan is, and trying to help them figure out what that means for software for the specific aircraft. And then, we work through the lower level designs and implementation, and then go through lots of rounds of testing. The software that we make is incredibly important. In a lot of cases, it's safety critical or it's mission critical. It provides the capabilities for our operators to stay safe in a theater where they're in combat. So there's a lot of criticality to what we do, which means with that seriousness, we go through lots and lots of testing to make sure what we're delivering is giving our end users the abilities that they need and keeping them safe while doing it. So test is a huge piece of that. And I know test has been mentioned in previous conversations. So we have safety nets in place, checks and balances to make sure that what we're doing is truly the safest that it can be. But in the software org alone, we do unit level testing, integration level testing, all the way to higher levels of buy-off testing at different levels of boxes, as we call them, or LRUs, computers, groups of computers, that sort of thing. Software is everywhere nowadays. Curtis mentioned phones. Phones have lots of software. Even your light bulbs, if you have the right toilet, it may have software. It really is everywhere nowadays. So all of the things we put onto the aircraft as we modernize, especially our legacy programs, have more and more pieces of software, adding more and more intricacy that our organization is responsible for, understanding how we're going to integrate those things together and make that magic of software work. Day in the life of a software engineer, more and more our organizations are moving towards the agile methodologies or even DevOps operations. So day to day could look very different. We are constantly going through little mini iterations of designing the software, implementing and testing it, trying to get capabilities out to different customers or different levels of testers so that they can make sure that the software is doing what the customer needs to do, so we can empower our warfighters with the most cutting edge capabilities in the software. So day to day, you're meeting with teams, you're working with your peers in the software org, and even peers across different organizations. So we partner a lot with the systems engineers, we partner a lot with the systems testers, and make sure that we are all on the same page on what we're trying to do and accomplish, so that we're not pulling in different directions. A given day, you may be spending a lot of time thinking through what the design is. That could be doing UML-like diagrams, thinking through the passing of messages across different pieces of software. It could actually be heads down, you're coding. We do a lot of our coding in C++, given that we're embedded software, or C. There's some programs that are using Java, and then we do a lot of tooling in Python. So between those languages, that covers a lot of what we do. There's obviously a lot of other things that we create that use other languages, but those are the bulk of the work. And then, we're going through the unit testing. We use different unit test frameworks to help with that process. Automated tests is a big push right now. If you're in school, that's a no-brainer, but the software industry has evolved a lot in the last few decades, and some of our aircraft, like the B-2, are 30 years old. And so we're trying to help make sure that today's technologies are empowering a platform like the B-2 that is 30 years old to have the best, most cutting-edge software out there to make sure that we're able to protect this country. So yeah, we are looking for computer science majors. You have oddballs like me that took the electrical engineering path and wound up in software, computer engineers. We even have sometimes mechanical engineers that come over to the good side, I like to say. And even biology, lots of people end up in the software field. So there's no one shape fits all. But well, if you have software experience, we're happy to talk to you.
Great. Thank you very much, Tracy. Bet you didn't think a mechanical engineer could do software, but they can. Here's a quick video about the B2. We've heard a lot of stories about the B2, and we want to show you a video. Seen some still photos, which are awesome. But here's what it sounds like.
When you fly the B2, you put in a set of earplugs, and then you put on an Air Force helmet also on top of those earplugs, and you can still hear it in your soul when you push the throttles up to max. It's an extremely powerful machine, and you never forget how powerful it is based on that sound the entire time you're flying.
Now I have the pleasure of introducing another person who's worked on the B2, Elise Huff, who is also an alum of Cal Poly Pomona. She graduated, I think it was 2017, and then you're gone on for a master's, pursuing it, and you're almost done with it, which is great, from Cal Poly Pomona. Very active in multiple organizations when Elise was at Cal Poly Pomona, being in SWE, being a leader in the collaboration project with Cal Poly SLO, and ever since she's been with us at Northrop Grumman, she has exercised her technical and people leadership skills at all times. And she's just a fantastic person. I can't wait to turn this over to Elise, and you'll hear more about Northrop Grumman from her.
Thank you, Norm. I really appreciate the introduction. Like Norm said, I'm a Cal Poly alum. I'm actually defending my master's thesis on Monday. So I am not only a Northrop Grumman engineer and here to talk to you about how great Northrop is, but I'm also here to commend what you guys are doing and how difficult getting a degree in engineering is. And through Cal Poly Pomona, it's a very great school. And I'm doing both of those at the same time. So it can be done. But it is definitely a rewarding task. I would encourage it. So I'm going to be here representing vehicle engineering. So some of us have talked about test, some of us have talked about software, right? The brains of the vehicle. In vehicle engineering, just as it says, you're building the structure of the aircraft. You're building the vehicle. So in Palmdale, we have large production lines like you see here for the F-35, and one of the engineering disciplines within vehicle engineering is liaison engineering. So their main role is to support the production line. They'll investigate and do analysis to resolve some type of engineering problem we might have with either design problems we find as we're trying to put something together or as we're fabricating it, right? Human error exists. So even if we have a perfectly good design, we might have errors or mistakes come up as we fabricate it. So you get these very interesting coupled problems that really require you to coordinate with a bunch of different personnel, a bunch of different engineering disciplines, and come up with a solution to whatever that problem is, right? Whatever that type of non-conformance is. So we have engineering drawings, we have the way it's supposed to be built, right? And at the Palmdale Aircraft Integration Center of Excellence, right, that's where we integrate the aircraft. We take those designs, that analysis, that initial vision, and we try to build that aircraft. Well, we have non-conforming assemblies and installations that happen all the time. And we have to figure out, okay, what do I have, right? What do I have to work with? We have certain constraints just from the design build, but also I need this to still fit in a certain spot, right? I still need this to perform a certain function for that vehicle and for the mission. So it's a very coupled problem. And in order to resolve that, you have to be able to come up with some type of repair that's going to bring it back to its original strength or its original capability. So you have all these different disciplines that are going to eventually feed into that repair idea. The liaison engineer has to identify what the root cause of that problem was and resolve not only how to fix this one situation, but to not allow that to keep happening. But they also have to really own the repair idea. It's a very creative role where you have to come up with, how am I going to design a repair for this? I need to make sure I keep the materials processes teams happy and I use acceptable materials for this aircraft or for this chipset, whatever it is. I need to still have my LO signature so that I have an acceptable radar cross section. I still need to be able to have structural integrity so that my stress analysts have what they need. So it's a very, very constrained creative process that they have to go through in order to come up with how they're going to make sure that the repair that they ultimately end up implementing follows through all of the failure analyses that need to be done and maintains all of the requirements for all the other disciplines. It's a very cross-discipline role. So one of the main key areas of expertise, I would say, is interpersonal communications, and you need to have a really big scope picture understanding of structure of aircraft and all the different materials and designs, analysis, everything that goes into what repair is going to be better than another. So I work with liaison engineers every day. They're the best. You need them to build things because humans are building them, so we're not going to do it perfectly. We are going to have non-conformances. So one of the other disciplines that they have to work with is structural designers. So they're responsible for putting together what that preliminary structure is going to look like, right? What would it be if it were pristine? So they're coming up with the structure, the ribs, the skins, how everything's going to be put together, how we're going to be putting all of those subsystems in for flight tests and for software, right? So how are we going to stuff everything into this aircraft structure and again, still maintain all the requirements for the other disciplines? So they have to understand the entire airframe. They need to know how the design is going to be put into not only a structural layout, but how they're going to fit all of the electronics inside. And in order to do that in a detailed and defined way, we have very detailed drawing releases and reviews amongst multiple different layers of structural design leadership. So they have to coordinate with the systems engineers like Curtis and make sure that we're meeting with all of those requirements and have everything in the design that's necessary. And they still have to collaborate with the structural analysis engineers like myself, because you can come up with a perfect design, but if the structural analyst says the physics aren't going to make any sense, then you have to keep that in mind. So areas of expertise, we work a lot with composites, so fabricating and repairing those. We also have metallics, bringing all of that together in a manufacturing environment. GD&T, so like your SolidWorks or your CATIA or NX type classes would prepare you for that. And then making sure that it's very lightweight because it is still an aircraft structure that's flying and weight is money. So vehicle integration, that would be putting all of those different aspects together, right? You have the electrical subsystems that have to be stuffed inside, all the mechanical subsystems, and being able to configure that in the aircraft such that it can carry out the mission that it needs to do. Can we fabricate this? Can we actually put it together? Are we going to be able to have enough area for testing? So a day in the life of a vehicle integration engineer would be to pulling all of those together and actually creating an integrated solution between all of those subsystems, making sure that you have a good communication with your customer for sure, because it's ultimately their product. Like it's our product, but it's for them, right? So keeping them in mind, keeping what they asked us for, what was in the RFP, right? Are we making sure we're integrating all of the requirements that they asked for? Are we passing all of our acceptance tests that they requested from us? So again, it's a very full view of the aircraft, right? Everything that goes into a running vehicle, the fuel, hydraulics, ECS, everything. For materials and processing engineers, so this would be, this could honestly be like any type of engineering, because a lot of them end up covering this type of topic, but it's mostly materials, processes, sometimes chemical engineers will get into this. So it's what materials are you using? What are the capabilities? What are the material properties, the strengths, right? What are the pros and cons of these? When do we use them? When do we not? So they're more about the raw materials and what the capabilities of those types of raw materials can be used for. So in vehicle engineering, right, that might be how do we build our radar cross-section around the B-2 such that it can be as small as a gnat, right? Or what types of metals should we be using? What types of composites should we be using for different applications? So it's much more related to the specific materials and how we might use those, or how we might apply those onto a certain aircraft or vehicle, whether it be composites, metallics, non-metallics, right? So that would be like your RCS, your magic sauce that goes on the B-2. And then I'm gonna try not to be impartial, but I'm a structural analyst. So as a structural analyst, you have to be able to pretty much do your strengths of materials classes, your stress analysis, finite element modeling. You need to be able to know how the load goes through the vehicle and still maintains its capability to carry out its mission, right? You have to understand different failure modes. You have to understand how a metallic or a composite structure might fail, right? What margins of safety do I need to assess to make sure that this structure is going to be sufficient, right? Is that static analysis? Is it durability and damage tolerance analyses? So for fatigue, right? We have to deal with all different types of load sets, all different types of stresses. The B-2, for instance, is extremely, it's loud, it's acoustically loud, like you heard in that video, vibration like crazy, you have wing bending, you also have pressure distributions from airflow outside of the aircraft. You also have pressure internal to the aircraft. All of those are very coupled structural problems. And we have to be able to build detailed finite element models and do very detailed hand calculations from scratch. I'm talking like on a piece of paper with a pencil as well as in Excel, right? And you validate that with your finite element model. But you're still doing math and science. Like you're still doing math and physics every day as a structural analyst, which is why I chose it personally. I think it's fantastic. It's very, very fun. It's very challenging. It's very rewarding. And you have to be able to put all of that analysis into a detailed report that anybody, whether they're a stress analyst or not, can pick that up and understand what you did and why you're confident and why you have a structurally integral structure that you can hand off to the software engineers or the test engineers and know that that is going to carry out its mission and be structurally sound. So in your classes, right, classical hand calculations, Excel, hand, on a piece of paper, all of that, and then any type of finite element modeling skills are going to be extremely important. Predominantly Nastran, Patran, and FEMAP as well. Sometimes we're starting to use NX a little bit as well. So if you have that knowledge, it's very transferable, but very detailed, very analytical heavy, very, very math based, but extremely fun, I promise.
Excellent. Very good. Thank you very much, Elise. Thank you, Audriana. Thank you, Curtis. Thank you, Tracy. We are through the tour, a very quick tour, albeit, but a tour of a number of days in the life of our engineers and why they all have fun. Because there's all different things to do here at Northrop Grumman to produce the really cool airplanes and spacecraft that we do here, and we need engineers like you. So keep working really hard, get your degree, and continue asking your questions in the chat window. And we look forward to following up with, and we'll have time for some Q&A after I play this video for you. So let me play this video.
Remember when the next big thing really was big? Really, truly, epically big? So big, the world would literally stop just to get a glimpse of it. Boys and girls would dream endlessly about it. And history books all had to be rewritten for it. Makes the latest smartphones, search engines, and robot cars seem downright tiny in comparison, doesn't it? Well, most of the next big things we all know and love came from one place. America's aerospace industry. In fact, American aerospace was the birthplace of innovation. Real innovation. And you know what? It still is. Today, we're inventing the next big thing in unmanned vehicles. The next big thing in space telescopes. The next big thing in microscopically small things. And the next big thing of stuff we're not even allowed to talk about. This is what we do. Because when you break free of the bureaucratic shackles, keep pushing the boundaries of what's possible, and radically advance human discovery, you're able to do something big, something really, truly, epically big. Build the next big thing of next big things.
So that concludes our formal presentation, and I look forward to any questions that haven't been answered in the chat, or if there's anything that you'd rather ask live of us, we're here for you.
All right, students, feel free to add some more questions. I know the NGC team has pretty much answered all of them in the chat box as we've been going. They're fantastic.
Thank you, NGC team.
But if there is any other questions, or if anyone wants to ask a question live, please just raise your hand and we'll call on you. All right, so we did get one question. It says, how long does the hiring process typically take?
Well, I'll let Melinda handle that one.
Can you hear me okay?
Yep.
Excellent. Hi, everyone. So to be honest, it's going to depend on where we are in the cycle, but in terms of what to expect, as you can imagine, we are starting our internship program for the summer right now, so we are full for this summer. But come August is when we're going to start looking for our next set of great students who are looking to come in. So we'll be starting to post roles in the August timeframe, and then as students go back to school, August, September, even late into October, is when we're going to start doing that recruiting process. It will depend on when we're ready to go through the interview, but I would say once you do have an interview, we should be able to give you an update within 2 weeks regarding if there's going to be additional interviews or additional people we want you to talk to, or if we're ready to make that offer. One thing I will mention for those of you who are actually asking about those potential internships either in the fall or the spring, we definitely are looking for students who are interested potentially in working during the school year. But as several of our folks here will tell you, a lot of our statements of work do require that you not only have that DoD, but you have program access. So that sometimes takes time. So while we may be looking for folks come this fall, the time that you'll be able to actually start working could depend on how long it takes for both of those things to go through. So that's another little bit of a caveat in terms of how quickly we could get you on board if you're looking for something maybe part-time this fall or this spring.
Hi, Ms. Johnson. I have a quick question.
Sure.
For those, for working during the school year, right? I know you guys are on Palmdale. Does that mean that if students who got accepted for the school year, they'd be working on campus, or were they expected to come to Palmdale to do that?
That's a great question. I would say the majority of students who are going to be working at the Palmdale location, as I just mentioned, you do work on programs that are highly classified. So most of the time it would require you to come on site. Norm, anyone else want to add on to that?
True statement. Simple as that. We would prefer that you were on site because of the classification. Actually, prefer is too soft a word. You have to work on site.
Okay, we do have one
I had
hand
a
up
question.
from Jason.
Yes, I have a question. So ever since COVID, I realized that this may be misunderstanding, but both Northrop Grumman and Boeing, they only recruit people with experiences. Is that a trend or?
Well, I can't speak for Boeing, but I can speak for Northrop Grumman, and we hire a lot of college grads. We've been doing that for a very long time, and we're going to continue to do that. We also hire experienced people, of course.
Because right now, if I see the jobs, majority or almost all of it requires professional experience of a few years. Should I wait for the batch on the fall?
You know, Jason, I think that's probably part of it, is that we do typically hire in cycles. A big reason for that is, as I mentioned, those clearances. So for those of you as students, since you most of the time will not have a clearance, we go through the process so we have enough time to make you that offer and then put you through not only a secret, but then again, maybe that program access. So we often do, for entry-level positions and internships, hire at very specific times. So it may just be a timing factor. So I would say definitely start looking for those entry-level positions that don't require that extra years of experience around the end of the summer. You'll probably see them popping up again.
Thank you. That's really helpful.
Okay, so we are getting towards the end here of our session. I know that some of the Northrop Grumman folks that were in the chat said that they would share their LinkedIn, so I'll give them the opportunity to do that now before we close everything out. And first, I would just like to say thank you so much to everyone from Northrop Grumman. They had a huge team here, and they were able to provide answers to all of your questions, and they took a lot of time preparing this event for us. So thank you. Let's give them a little round of applause. And thank you so much for attending. As a reminder, all of these have been recorded and they will be available at a later date. We will email all students when they are available. So this concludes our event. Yes, you're welcome. Thank you so much, Norm. And I will leave it open so that way folks can pull information from the chat if needed.
Okay, great. Thank you very much, Chelsea. I really appreciate it. Thank you, Cal Poly, Mac. I see Carrie was here as well, and all the students, everyone from Northrop Grumman. I appreciate everything that you've done to prepare for this day. As there are probably more questions than we've had a chance to answer either live or through chat. I'm sure, Melinda, if you could give them a means to follow up with us, we are more than happy to just answer, I should say, to answer every question that you have, because we want to be able to reach out to you and encourage you to apply. So thanks again. Good luck in your studies. Do well. And we hope that you'll get an opportunity to solve really hard, nationally and world important problems that we do here at Northrop Grumman. Thanks, everybody.
Thank you.
So students, feel free to grab those links in the chat box. I'll be closing the room in about 1 minute.